To verify or prove the given functions are inverses, you must prove the following: that f of g of x is x and g of f of x is x. We're going to put the f function in for the x in the g function, and we're going to put the g function in for the x in the f function. I like to put a big fraction bar because I know that there's a whole function that's going to need to be input here. Then we have a +3 and a -1. That entire function that needs to go in these parentheses is the g function. That would be -2 over x plus 1 plus 3. We have a fraction within a fraction here. So your first goal is to simplify everything in the numerator of that fraction and to combine or simplify everything in the denominator of that fraction so that you only have one piece over one piece and you can divide those. First, we have a lot of work to do with the denominator. First, we're going to distribute this negative. +2 over x plus 1 times negative times a positive is -3, and then you have +3 still in the denominator and a -1 outside of the fraction. Now I can combine like terms, such as -3 and 3 is just 0, which will give me one piece on the top and one piece on the bottom. Now that I'm dividing 2 by 2 over x plus 1, I will rewrite it as 2 over 1, that's my numerator, times the reciprocal of this one, so x plus 1, remember it's all a group, so it needs to be together, over 2, and then -1. 2 over 2 is just 1, x plus 1 minus 1, and you get x. Yay, we've proven that it's x. Now we gotta do the other composition. Okay, now I've plugged it in the opposite way. I'm going to take this negative. It belongs to the whole fraction, so it either belongs to every piece that's in the denominator or it belongs to every piece that's in the numerator. Since there's only one piece in the numerator, I'm going to apply it to the numerator. I just don't want it to forget about it. Sometimes a negative in front of a fraction bar kind of just blurs together. So this will be -2 over. Now, these parentheses are actually unnecessary because we're not distributing this negative. Nothing's being multiplied like the last time, and all we're doing over here is adding. So I'm going to write it without parentheses, -1, +1, and then +3. Ooh, -1 plus 1, that is 0. -2 over the fraction 2 over -x plus 3 plus 3. Skipping steps is not what you want to do on these problems. These are proofs. You are verifying. So if you say, oh yeah, it equals x and don't show me how, you're not going to get the credit. This is a -2 over 1 in the numerator times the reciprocal of the denominator. So -x plus 3 over 2 plus 3. -2 over 2 is 1. But please, please, please do not forget that there's this negative here. So really, it's a -1 that those 2 over 2 turned into. Now, -1 does need to be distributed into this parentheses, and that's why we put parentheses around the grouping, so you don't forget that it applies to both parts. +x, -3, and then drop the +3 so that you do end up with just x. And then you know that these are inverse functions. You have proven it. Number 2, we're going to plug in the g function into the f function where you see the x, and vice versa. Underneath the cube root is where the x is, but 4 is being multiplied by x, so I'll put 4 and then these parentheses to plug in the entire g function, which is -2 times x minus 3 quantity cubed. It's really important to recognize that you cannot cross off these 3's unless everything underneath here is a product. And then you can cube root everything underneath here if you want to. This 4 and negative 2 are also under the cube root, so we can't just cross off the 3's and pretend that we never had to take the cube root of this product. So to begin, I know that I cannot cube root 4. There's no perfect cube for that. I know that I can't cube root negative 2, but 4 times negative 2 is negative 8, and that is a perfect cube. Yay! And that is being multiplied by x minus 3 quantity cubed. Everything under the cube root is cube rootable. I don't know if that's a word. Anyway, so I'm going to separate the cube root to be the cube root of negative 8 times the cube root of this quantity cubed, all over 2. Yes, now we can cross off these 3's because everything that's inside of this cube root is being cubed. Now we can't cross off any 3's, there's no 3 here, but we can evaluate the cubed root of negative 8. What is the cubed root of negative 8? That is negative 2. Negative 2 times negative 2 times negative 2 is negative 8. That is being multiplied still by this quantity, x minus 3, but it's no longer cubed or cube rooted, all over 2. I would like to combine these negatives, make that a positive. First of all, 6 plus 2 times x minus 3 over 2. Okay, nothing can be crossed off in your numerator and denominator until everything in the numerator and the denominator are a product. See this? That's a plus sign, so we can't do that. We have to break down the entire numerator before we can cross off things with the denominator. 6 plus 2x, we're going to distribute this so that we can combine like terms. Negative 6 all over 2. Still can't cross things off yet. Still can't cross off the 2's, but you do have a 6 and a negative 6 in the numerator. That makes 0. So now we have, now there are no plus signs. Everything is a product or a quotient in here. And 2 over 2 is 1, so you're left with x. All right, halfway done. As I plug in the f function into the g function, you have 6 minus the cubed root of 4x all over 2. Here you may be tempted to want to cross off your 3's, but you can't. You have to break down and simplify everything until you can apply the exponent of 3 to both the numerator and the denominator. The first thing I'm going to do is to separate this fraction. 6 over 2 minus cube root 4x over 2 minus 3 quantity cubed. 6 over 2 is 3 minus cube root 4x over 2 minus 3. 3 minus 3 is 0. Negative cube root 4x over 2 cubed. And just so I don't forget about this negative in front, I'm going to attach it to the 2. Not everything inside of the parentheses is under the cube root, so you still can't cross off the little 3's. But you could apply the little 3. You could say, oh, this means the numerator is being cubed and also the denominator is being cubed. And how do we write that? We'd say cube root of 4x is being cubed over negative 2 being cubed. Is everything inside of this parentheses, is it under the cube root? Yes, it is. Now you can cross off the cubes. You have negative 2 times whatever was under here, 4x, over, what is negative 2 to the power of 3? That is negative 8. Negative 2 times 4x is negative 8x over negative 8. Negative 8 over negative 8 is 1, and you get x. So these are also inverse functions. To find the inverse function, we must know the relationship between inverse functions. And inverse functions swap the x and the y. So the first thing I'm going to do is I would like to write this function in terms of x and y. So instead of f of n, I'm going to write y equals 1 over, and then instead of n, I'm going to change that to x. You don't have to, but I'm just more comfortable with it. The next step is to completely swap the positions of x and y. So x would go here, y would go here, and then now we need to solve for y. We need to get y by itself. So the first thing I'm going to do is start furthest away from the y and start using inverse operations. So minus 2 on both sides. X minus 2 is equal to 1 over y plus 1. Y is in the denominator, and I have to get it out of the denominator. So even though I would like to just leave y on this side and move everything else, I can't. I have to multiply this quantity on both sides to get y plus 1, to get the y out of the denominator. Now we're not going to distribute these because we don't want y with other stuff. We want y away from other stuff. So at this point, we're going to divide by x minus 2 to get the x to the other side. And now you have y plus 1 equals 1 over x minus 2. My last step is to subtract 1 on both sides. That's my last algebraic step. And then, of course, we need to write the notation for inverse functions. So going back, we had an f of n. So this is now f inverse of n is equal to 1 over, replace the n put back with n minus 2 minus 1. I've plugged in y for the f of x, and now I'm going to swap the places of x and y and solve for y in its new position. The entire right side of the equation is being divided by 2. So if I want to do anything to the terms on the top of this fraction, I'm going to have to multiply both sides by 2 to get rid of the fraction entirely. 2x is equal to 2 over 2 is 1, negative 4 minus 5th root 16y. You start furthest away from y on the same side as y and move things over with inverse operations. So this negative 4 needs to be added on both sides. 2x plus 4 equals negative 5th root 16y. At this point, if you are just going through the motions on how to find an inverse, you are going to be so confused with how the answer key came up with its answer, because you're not going to simplify it as much as you should, and the answer key simplifies it the most. At this point in time, before I divide this negative 1 and get it on the other side so that I can finally get rid of this root, I see something on the left side. There's a GCF in both of these terms. So I would like to take that out now. I can't take it out after I have decided to put everything to the power of 5. And I'd rather take it out before dividing by negative 1 and changing all the signs. 2 times x plus 2 equals negative 1 times, that's what that negative means, 16y. Now I'm going to divide by negative 1 to get it onto this side. That is negative 2 quantity x plus 2 equals fifth root 16y. Okay, everything on the right side is being fifth rooted, so let's put it to the power of 5. On the left side, we have a product that is being put to the power of 5. So we can actually separate and apply the little 5 to each piece. So that would be negative 2 to the power of 5 times the quantity x plus 2 to the power of 5. Now the quantity x plus 2 to the power of 5 is just going to stay, but negative 2 to the power of 5, that you can actually simplify. So this is now 16y. What is negative 2 to the power of 5? It's negative 32 times the quantity x plus 2 to the power of 5 equals 16y. Last algebraic step is to divide both sides by 16. Negative 32 over 16 is negative 2 times x plus 2 to the 5th equals y. What did we start with? We started with x and f of x, so we're going to write that notation now. F inverse of x is negative 2 x plus 2 quantity to the 5th.